Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're going to talk about numerical sequences. Now, what is a numerical sequence? Let's see. Now we need to complete each of the patterns of numbers below. Now this is 1, 4, 7, 10, 13. How do we continue? We are adding 3, as you see. So if we add 3, we get 16, then 19, then 22, and so on. And if we want to write it in terms of n, we get 3n minus 2. Now, how do we get 3n minus 2? We have to search for the relation that exists between this number and this rank. This is called a term and this is called a rank. Now, it's not that clear in the first rank. Now, here we can see that 4 is triple this number, minus 2. For example, 7 is triple this number, minus 2, and 10 is triple this number, minus 2. Now we can also see that this 3 is related to this number. Now let's take another example. We have the first term is 3, 6, 12, 24, 48. So what are we doing here? We are multiplying by 2. So the next term would be 96, then 192, 384, 768 by multiplying by 2. And in general, the final answer in terms of m would be 3 times 2 to the power n minus 1. Now, how do we find it also? We have to find the relation between the term and the rank. We are always multiplying by 2, but we multiplied by 3 also. Now, let's see this pattern of numbers 1, 4, 9, 16, 25. Now here, as you see, we don't have any relation of addition, subtraction, multiplication, or division. In fact, we have to see the relation between the numbers. We can see that these are the perfect square numbers. So this is 6 squared, 5 squared, 4 squared, this is 7 squared. So here we're going to have 8 squared, and here 9 squared. And in general, we are talking about n squared. Now, this could be called U1, so this would be U2, U3, and so on, U4, U5, U6, U7. So U7 is 19, U7 could be 192, U7 could be 49, and so on, U8, U9. In this case, I'm going to call the last term the nth term. Now, this is not necessarily, because the first term could be called V0, for example, and if the first is V0, the second would be V1, and the third would be V2, and we have also to find a relation between the rank and this number. So V3, V4, V5, V6, V7, V8. So the last one would not be Vn, it will be Vn minus 1. And this is also not necessary, because we could begin with W5, and if this is W5, this would be W6, and then W7, W8. You see, if this is 4, this would be 8, so we are adding 4. This is 9, this is 10, this is 11, 12, 13. So if this is the nth rank, the nth term would be called W of n plus 4. Now, the most frequent forms are these two. So the first term could be either called U1 or U0, V0, but this is not necessary, because it could be called also, as you see here, W5. Now let's see the relation between the numerical sequence and the function. Remember the definition of a function. It's a mapping from a subset of R onto R. And this is its notation. We usually call it f, and it goes from x to f of x. And f of x is called the image of x. This is function f, which is defined on R as f of x equals. You see, the name of the function is f, and we have a relation between f of x and x, because one of them is the dependent variable and the second one is the independent variable. The question is find if possible each image. So f of x is called the image. What is f of 0? So we replace each x by 0, we get -1. F of 2 is 5 over 3. F of 1.5 is 0.5. F of -3 is 5. F of radical 2 is 1 over 3. And f of 1 is -1 over 3. I'd like here to remind you by the meaning of subset of R onto R. Well, x could be any real number here, and f of x could also be any real number. You see, you can choose any real number for x, and the answer could be any real number, because here the domain of definition is R. Now let's make a comparison with the sequence. Well, what is a sequence? A sequence is a mapping also, but from a subset of n onto R. So the first difference is that the function is a mapping from a subset of R onto R, whereas here it's a mapping from a subset of n onto R. And in fact, this happens because in sequences we talk about ranks. So we find the first term, second term, third term. So first, second, and third are terms which are used in n. Now, what is the notation? It's usually denoted by parentheses un close parentheses, and it goes from n onto un. You see the similarities. The terms of the sequence un are u0, u1, u2. So we don't usually use the same notation like this, but they do look like each other. Un is called the general term of the sequence. Now, if we take this sequence, which is somehow the same as this function, you see here n belongs to n, and we need to find, if possible, each term. Now, what is u0? We replace each n by 0. We get -1. It's the same as f of 0 is -1. What is u2? We replace each n by 2. We get 5 over 3, and we get the same answer. Now, what is u of 1.5? In fact, u of 1.5 does not exist because 1.5 does not belong to n. Remember, this n should belong to n, and 1.5 is not a natural number. And in fact, we can talk about the second term, the first term, the zeroth term, but we cannot talk about the 1.5 term. Now, what is u of -3? It's also impossible to find it because -3 is not a natural number. What is u of radical 2? It does not exist. And what is u of 1? It is -1 over 3. So if we just compare these two answers very quickly, we can see that in functions we can find many values, whereas in sequences we see that n should be a natural number, but the answer could be any value. Let's see. Now, the blue one is a function, the red one is the sequence. Now, the blue one is the representative curve of the function 1 over 4x squared minus 3. You see, we're going to have a continuous curve here. Whereas for the sequence, which is un, which is 1 over 4n squared minus 3, in fact, we're going to have only points, as you see. So the function is continuous, whereas the sequence is discrete. So we just have points. Now this is Vn, a sequence for all non-zero natural numbers n. Remember always in sequences to see what are the conditions that exist for n. So in this case, n is a natural number, but it could never be 0 because it is in the denominator. The question is to determine the first three terms in the sequence Vn. Now here the first term is V1, it cannot be V0 because of this condition. While V1 we replace each n by 1, we get 2, and V2 is 3 over 2, and V3 is 4 over 3. So it's just a matter of substitution. Now notice that the first term here is V1 rather than V0, as I said before, because n is a non-zero natural number. Now this is the sequence Wn, which is defined as Wn plus 1 is 3Wn minus 2n plus 1, so it's related to n and Wn, and we have here W0. The question is to determine W1, W2, and W3. Now if we want to talk about W1, in this case small n plays the role of 0, so for n equals 0, W1 is a 3W0 minus 2 into 0 plus 1, which is 4. And in order to find W2 from this relation, W2 would be 3W1 minus 2 into 1 plus 1, which is 11, and similarly for W3. So we see here we cannot find W1, W2, and W3 unless we know the first term, which is W0, whereas in this example we can find any term that we like. Now, notice here that W2 depends on W1 and W3 depends on W2. Okay, now we have this application, we have the sequence UN, and n is greater than or equal to 2. Determine the first three terms in the sequence UN. Try to do it alone. Well, U2 is 5, we replace each n by 2. Remember, we began by U2 because n is greater than or equal to 2. U3 is 7 over 2, and U4 is 3. Now we have also this sequence, which is defined as Rn plus 2, which is Rn plus 1 minus 2Rn, and here we have two initial values, R0 and R1, and we need to find the first 5 terms in the sequence. Try to do it alone. For n equals 0, we see that R2 is R1 minus 2 R0, we replace. For n equals 1, we also replace, we get 0, and for n equals 2. Now we have Vn and Un, a relation between them, and we need to find V0, V1, and V2. Try to do it alone. We see that V0 from this relation is U0 minus 5, and we know U0. And in fact, to know V1, we need U1, so let's calculate it first. What is U1? It's 2U0 plus 3, which is 5. So what is V1? It's U1 minus 5. Again, to find V2, we need, from here V2, we need U2. So we calculated before, and so on. Now, determination and sense of variations of a numerical sequence. A sequence is determined either explicitly or recursively. An explicit sequence is a sequence such that Un is given in terms of n, such that Un is 2n squared minus 3 over 3, whereas a recursive sequence is a sequence such that Un plus 1 is given in terms of Un, together with a given term such that Un plus 1 is 2Un plus 3, and U0 is 1. So in the previous examples, we were dealing with explicit sequences and recursive sequences. Now, how do we find the sense of variations of a sequence? The sequence Un is said to be increasing if and only if Un plus 1 is greater than or equal to Un, and it's strictly increasing if Un plus 1 is greater than Un, and it's decreasing if Un plus 1 is smaller than or equal to Un, and it's strictly decreasing if Un plus 1 is less than Un, and it's a constant if Un plus 1 is equal to Un. So increasing or strictly increasing are related to greater, decreasing and strictly decreasing are related to smaller. Okay, we have this sequence which is Un, and the question is to study the sense of variations of this sequence. So we need to compare Un plus 1 and Un, whether Un plus 1 is greater or smaller or equal. Now, remember, to compare two numbers, we either use the difference method or the quotient method. Let's see. Now here, if we just want to tell whether it's increasing or decreasing, using scratch paper, U1 is 2, U2 is 5, U3 is 8, U4 is 11. So we can see that this sequence is an increasing sequence because it increases, as you see. Now we go on proving in terms of n. We find Un plus 1, and to find Un plus 1, we replace each n by n plus 1. We get 3n plus 2. If we want to find the difference method, Un plus 1 minus Un is going to be 3, which is positive, or greater than or equal to 0. So we can say from here that Un is strictly increasing or increasing. While we can also use the quotient method. Un plus 1 over Un is 3n plus 2 over 3n minus 1. And we know that 3n minus 1 is positive, which is the denominator, and we know that the numerator is greater than the denominator, so this quantity is greater than 1, and if it's greater than 1, we can say that un is strictly increasing. Now, which method do you prefer? It depends. Okay, try to do this application alone. Rima, Rami, or Mira. We have un is a sequence defined as follows, and we need to study the sense of variations of un. Rima found un plus 1 minus un, which is given as follows, and she said that this is positive because all the factors in the denominator are positive, so un is strictly increasing. Rami found un plus 1 over un, which is given by this quantity, and he said that this is positive since all terms are positive, so un is strictly increasing. And Mira said that un is positive because 2n plus 1 is positive and n plus 1 is positive, and she found the quotient un plus 1 over un, and she compared it to 1, and this is greater than 1 because the numerator is greater than the denominator, and she concluded that un is strictly increasing. Well, which method do you prefer? I think Rami's method is not correct because he compared the quotient to 0. Pay attention, we must compare the quotient to 1. Thank you.